Alright, so this is another video on my separator system. I'll probably do a couple since there's a good amount of devices here. I'll probably do a video on each one, but as of right now I'm just letting you guys tag along onto what I'm currently doing. So right now I'm messing with the controller still. So I ended up adding a third control scheme. So you got my high select, Cascade 1 and Cascade 2. If I were to hit on the notes, it'll pretty much tell you what the loop consists of. I'm currently working on on Cascade number 2. So as you can see, Cascade 2 will use LIC 6001 and FIC 6001 to control the level of the separator. LIC is the primary controller, FIC is the secondary controller, and FY is the final element, aka the control valve. So if I come to my actual system, this right here is my Cascade loop, and I'll go ahead and show you what devices I'm using to set this up. So once again, this is a LIT, right, level indicating transmitter, and this is the transmitter that I'm using to measure the level inside the tank. So this right here is the primary controller for the fact that this tank takes a good amount of time for me to fill it up from 0 to 100%, right? So I'd have to make this the primary controller for the fact that it moves relatively slow. Even if I turn on the pump 100%, it's still going to take some time for it to actually fill up. And so since that's the case, I would typically have to use a secondary controller, which I am in this case, called the FIC. So this right here is the flow indicating controller. And so what it's doing is measuring the flow rate of this pump coming out and hitting the final element. So this right here was the same valve I was talking about earlier, FY 6001. It is an air to open, so fail close, and this is the valve that I'm using to fill up the tank. So this right here is my secondary. My primary sensor is the LIT. My secondary sensor is my FIT, and my final element is my FY. And so now we come back to the controller. Once again, this is my LIC and my FIT. So watch what happens when I change the set point. So right now the tank is relatively stable, and a little hiccup here, but it's currently controlling at 25%. So I come over here, I can actually change it. Let's say I want to go to 35%, right? So as soon as I hit 35, look what happens. So the set point did increase, but if you notice this white line, this is the output. This output affects the input, which is the green line. So as you can see, even though this is making a big change, the actual change to the process is pretty much minute. Where if I look at this one, this is my FIC. See, the output is changing, which is gradually also changing the flow rate of the actual system. So as you can see, this controller is responding much more quickly than this controller. And I'm talking about the process variable. So as you can see, your PV, as you can see, like both controllers have an output of 100%, but this one's PV changed way quicker than this one. So this is what I keep as my primary controller, and this is what I keep as my secondary controller. So if I were to go back and say I want a set point at 20, let's see what happens. Let's see which one moves much quicker. And so they're going. Cut it out a little bit, it's taking a little too long, but watch this. As soon as this thing starts cranking down, this PV is gonna pretty much change pretty drastically. And there it goes. See that? Compared to this one. See, this one's moving real slow still. Even though the output changed pretty much all the way down, it's moving relatively slow, whereas this one, see, small change or small process response, fast process response. And so once again, the program that I'm using is RSLogis 5000. So this is my Cascade loop. So I have my primary controller, which has the set point of the LIC and the LIT, and then this is my secondary controller. which is my FIT and my FY, which is the valve that's controlling the whole process.